Hello, everyone, and thank you so much for subscribing to this first session of a series of several webinars, during which we'll be talking about data science and statistics. So today we're going to start with descriptive statistics, or how to simply describe data. We'll be talking about a few statistical tools, which will be quite simple, but yet super useful for you to gain insight into your data. I will be illustrating things with the XLSTAT software. I think that many of you already know the software. Otherwise, well, you'll be able to see how it looks like in a few moments. My name is Jean-Paul Maalouf. I work as a data science consultant with XLSTAT. So I promise that during this webinar and the upcoming webinars, I will try to be as intuitive as I can. I will talk to you, I will address you as users of statistical methods, as users of data science methods, and not as pure statisticians. And so I will avoid as much as I can reference to complicated mathematical formula. I will have an intuitive speech. You should know that there will be a recording of the webinar available, so you will receive maybe next week a link to the recording. So if you ever like the webinar, don't hesitate to share it with people who could be interested. Also know that there are handouts and data that you can download using the webinar platform. Normally there's a button somewhere that allows you to download the PDF of the handouts as well as the data, so don't hesitate to download them as well. You can ask questions all along the webinar using the chatting window. I won't be able to answer them during the webinar, but I will use the last 5 minutes or 10 minutes of the webinar for a Q&A session. So I will try to answer as many questions as I can. So let us start with an outline of this webinar. I will first start by saying who are we? So what is XLSTAT and who are we? Then I will talk about statistics. I will give you a definition of statistics. What is the difference between statistics and data science? Then I will show you my personal way of dividing statistical methods into different families of tools. Then we'll talk about variables individuals. It's very important for me to agree with you on the definitions of those very basic terms in statistics. You will see that there are different categories of variables. We will talk about qualitative variables and quantitative variables, and we'll see how to describe simply each type of variables. Then we'll investigate potential links between two variables, and we'll see each of the possibilities. So for instance, we'll see how to investigate the link between two qualitative variables, how to investigate the link between one quantitative and one qualitative variables, and at last, how to investigate the link between two quantitative variables. So let's start with an introduction of the software. Who are we? XLSTAT is a statistical software that works as an add-on to Excel on PC and on Mac. It's also available for Excel 365 and Google Sheets. You can also use the software on the cloud. Now, one of the main strengths of XLSTAT is that it works using Excel. So you can do everything in the analysis process inside your Excel file in which your data is already stored. So you really don't lose the user friendliness of the Excel interface to analyze your data. In a few numbers, XLSTAT holds more than 220 statistical features. There are more than 150K users worldwide, more than 25 employees working for the software, 300K monthly visits on the website, and the software is available in 7 languages, and we have offices in 3 time zones, offices in America and Europe, as well as in Japan. There are 10K monthly downloads of the software. Now, XLSTAT is developed by the Addinsoft company, and Addinsoft is located in a private lab named the Data Factory in Bordeaux, France. And the Data Factory also hosts 4 other companies which are based around data. And it's quite active in the world of data as it organizes more than 25 workshops, events, and trainings every year. So XLSTAT has 8 different solutions to meet your very specific needs. So first of all, there are 3 generalist solutions, Basic, Basic Plus, and Premium. The basic solution includes the top essential statistical methods you need to have for exploration, visualization, and modeling. Then Basic Plus has all the basic features plus essential machine learning features. Then Premium includes all of the 220 XLSTAT features. So between Basic Plus and Premium, we have intermediate solutions which are more field-oriented. So sensory can be used by sensometricians. So it includes features such as preference mapping and other features which are typically used in sensometrics. In life sciences, you will find tools such as survival analysis or omics data analysis or dose response analysis. In marketing, you will find tools for conjoint analysis, which is an advanced surveying tool for market research. In forecasting, you'll be able to analyze time series and risks. And in quality, you have tools that are typically used for quality control. Now, one thing you should know, all the tools or all the methods we're going to see today are included in all XLSTAT solutions. So from the simplest one to the most complex one. On the XLSTAT websites, there are more than 200 tutorials associated to downloadable datasets that you can follow step by step. So each feature in XLSTAT is linked to an intuitive tutorial in which you learn how to configure the dialog box and how to capture your data, and at last how to interpret the results. So don't hesitate to check these tutorials out. So you don't really necessarily need an XLSTAT license to be able to access these articles online. Also, XLSTAT develops a YouTube channel named Stat Cafe, which talks about different statistical features in a very, very simple way and in a short video formats. And each statistical feature is illustrated by a real life example using XLSTAT. So let us start with the bulk of this webinar. How can we define statistics? So I simply pasted the definition taken from dictionary.com. Statistics is the science that deals with the collection, the classification, the analysis, and the interpretation of data. Okay. Now, how about the definition of data science? So you surely all already heard this term, which has been trending for the last few years. Here's the definition I took from Wikipedia. So if you read the definition, you will find that it's quite similar in many points to statistics. So what would be the difference between data science and statistics? I would say that data science is a more global field that includes the statistics component, and the statistics is a major component of data science. So to be a good data scientist, not only you need to have strong statistical skills and data analysis skills, but also you need to have strong expertise in your own field, and also you need to know how to use data software, computational software, correctly. So data science is more general than statistics, but still statistics is a major component of data science. Now let me show you my own personal way of dividing statistical tools into several families, into 4 families. So first of all, there's descriptive tools. So descriptive statistical tools, which allow you to describe one variable or the link between 2 variables. we'll be talking about very simple tools such as the mean, the standard deviation, the histogram, and the box plots. Those tools, as I told you, are quite simple, but very, very useful. So very often you won't need to go further than this to gain insight into your data. So this will be the topic of today's webinar. Then, second family, tools for exploring and clustering data. So those tools allow you to easily extract information from large data sets without necessarily having a precise question to answer. So you will be able to gain insights into multivariate data sets, so data sets with more than 2 columns or 3 columns. So among the most commonly used tools in this family, we can mention the PCA, or Principal Component Analysis. We can mention correspondence analysis as well. Otherwise, we'll be talking about also clustering methods such as agglomerative hierarchical clustering, or k-means, within this family. Then third family, statistical testing. So statistical testing tools allow you to accept or to reject very precise hypotheses, assuming error risks. So we'll be able to investigate here questions whose answer is yes or no. So questions are very precise as compared to the question we may ask using the tools from the two first families. And at last, statistical modeling allows you to understand how a variable behaves according to a set of other variables, and optionally, statistical modeling allows you to make predictions. So as you can see, there are no very straight limits between the families. Some of the tools can be found in different families, such as ANOVA here. You can find it here, you can also find it here. So this is just my way of dividing statistical tools into different categories. In other references, you will find other ways, but for me, it's the simplest way to tell a story of statistical methods, from the simplest one to the most complex one. There are several webinars which are scheduled in the upcoming days and few weeks. So the day after tomorrow, there's a webinar on data exploration and clustering. So if you haven't subscribed and if you are interested, don't hesitate to subscribe. You have a link in the PDF to the subscription page. Then on the 21st of April, so this is next week, there's a webinar on statistical testing. Then another one on statistical modeling, in which we'll be talking about mainly about modeling in general and regression. And at last, there's a webinar on ANOVA. I know that many users of XLSTAT use ANOVA in the field of marketing, for instance, or biostatistics, or agronomy, or sensometrics. How can we define variables and individuals? So we'll be talking a lot about variables during all these webinars. It's important for us to make sure we understand what's behind this term. So a variable is simply a measurable element which can take different values. There are many kinds of variables, and I summarized them into two kinds. First, quantitative variables, so which are variables that can be quantified or expressed in numbers. So for instance, the number of items in a cart, a size, a weight, a price, or a score in a survey from 1 to 10. Then we have qualitative variables, which take categorical values or nominal values. So qualitative variables cannot be quantified. You cannot express qualitative variables using numbers. So for instance, a social professional category, the gender, the geographical origin, the experimental treatment, for instance, in biostatistics or in clinical trials. So yeah, we have two broad types of variables. So there are many subcategories, but I wanted to stay to be quite synthetical in these webinars and not go into deep details, because we really don't have the time to see everything in just in a few hours. So let's stick to these two broad definitions Now, what is an individual or an observation? So this is simply the elementary statistical unit that can be described using variables. So this can be a respondent in a survey, this can be a client, it could be a patient in biostatistics, it could be a plot in agronomical research, or measurements on a machine if you're working on quality control. Now, how can we represent individuals and variables in a typical data set? This one, for instance. So this data set will be quite used in all the webinars I will be animating in the few coming weeks. This is the data from an online shoe selling platform that represent individuals in rows and variables in columns. And this configuration is quite common, and this is the configuration you should have in any for the analysis in any statistical software, not only XLSTAT. So individuals or observations in rows and variables in columns. So what do we have here? Each row represents one client, and each column a variable characterizing these clients. So we have the origin, the gender, the height, shoe size, weight, the time the client spent on the website, the preferred brand, and at last, the invoice amount. As you can see, there are qualitative variables such as origin and gender, preferred brand, and quantitative ones such as height, shoe size, weight, and time spent on the website, and invoice amount. So remember, observations and individuals in rows, variables in columns. The data are made up. Now, how can we describe one qualitative variable? We'll start with this very simple case before switching to how to describe one quantitative variable. For instance, take preferred brand. How can I summarize the information included in this column? The main tools that are used for this are counting frequencies, simply. So frequencies are simply the number of observations per category, which can also be expressed in terms of proportions. So we'll be counting the number of times brand A occurred in this column, the number of times brand D occurred in this column, C and B, etc. So we'll be able to investigate which was the most popular and which was the least popular brand in our database. Then we can also characterize our column with the mode, which is the most frequent category. Frequencies can be visualized using two visualizing tools, bar chart and pie charts. Let me show you how to obtain these statistics using XLSTAT. So I will just switch to English. Okay. As you can see, XLSTAT is included or is embedded inside my Excel file in which I have stored my data. Okay. So within each of these menus, you have statistical features that you can configure and in which you can capture data to obtain quickly your analysis inside your Excel workbook. So we'll be mainly focusing today on those two menus, describing data and visualizing data. So my aim is to describe this column here. I will simply click on Descriptive Statistics. Okay. This is a typical XLSTAT dialog box. It is composed of different tabs in which you can capture data and you can also configure options. So in my case, my aim is to describe qualitative data. So I unchecked quantitative and I checked qualitative. So in this field, all I need to do is to select the data I want to describe. Here I want to describe preferred brands, so I'll select the data like this. There are other ways to select data in XLSTAT. So you can also select the data just by clicking on the header of the column. So on letter H here. In this case, the whole column is selected, so you don't need to drag your mouse until the end. There are also other ways of selecting data in XLSTAT. If you click here, you can also select your data using variable names. So here, if I want to select the preferred brand, I just click here. Okay. I know that many of you are used to other software where data selection goes like this, but I'm pretty more used to the classic XLSTAT selection method. So here we go. Then I will go to the Outputs tab. And as you can see, there are two lists of statistics. One list is for quantitative data, which I cannot really play with. Why? Because I haven't selected any quantitative data here in the General tab. So the qualitative data field is activated. So I can select any statistics I want to obtain. I will just take the number of observations, for instance, the number of categories, so how many possible brands do I have, the mode frequencies, the categories, as well as the frequencies per category. I will also take the percentages, just uncheck all of these, don't really need them. Then there are two charts tab, charts 1 and charts 2. Charts 1 is for quantitative data charts, and charts 2 is for qualitative data charts. So I will activate bar charts and pie charts here. Let me click OK. And here we go, we have the results that appear in a new Excel spreadsheet. Okay. So these results, you can simply share them with your colleagues or your clients, in the form of Excel workbooks. So if you save this report in the form of an Excel workbook, you can share it as an Excel file to anyone, and the recipient doesn't necessarily have to or need to have an XLSTAT license to be able to read this file, this report. So we have the statistics relative to our preferred brand variable. We have 30 observations. This is the number of rows in our dataset. We have 4 categories, so 4 different brands. The mode corresponds to brand C. This is the most frequent category, the most popular brand in our database. So it's been selected 12 times in the database. Then we have a counting of the frequencies for each category apart. So we have brand A, which has been selected 10 times, brand B 4 times, C 12 times, and D 4 times. We see that the most popular brand is brand C. See it also here. And then right after it, we have brand A. And of course, this can be represented in terms of percentages. This is the bar chart. So this is a representation of frequencies. We have the frequency of each brand. And one thing you should know is that most of the charts produced by XLSTAT are actually Excel charts, which you can customize using the Excel options. So I will go there and just customize the shapes and the colors and the fonts. So for a second, change the font here, do whatever I want. Okay. Then for some Excel versions, you also have special templates here, which are already designed for you, that you can toggle among. Then this is the pie chart. I think that most of you know how to interpret this. So each brand is represented by a color, and the proportion of each section of this chart is represent the proportion here in the frequencies. So we're able to find out the mode once again, which is the green brand C. You should know that you have all the different configurations inside the PDF presentation. So if you want to replicate this analysis on these data or on your own data, you have a guide here. Okay, and you also have the comments on the results. Now we finished describing one single qualitative variable. How to describe one single quantitative variable? For instance, shoe size. How can I summarize the information of this column? Well, mainly we'll be talking about central tendency and dispersion. So the central tendency, how can I describe the middle of my data? We'll be using mean and median mainly. So these are the most popular statistics that are used to describe the central tendency of a series of quantitative data points. Then we'll also talk about dispersion. So to what extent are the data spread around the central tendency? So the most popular tool here is the standard deviation. We'll also investigate histograms, which allow you to represent the variable's value distribution. So are the values more concentrated right below the mean and more spread above the mean or not? So the histogram allows us to investigate this. And at last, the box plot is a graphical representation of both central tendency and dispersion, and also allows us to see whether there are extreme data points in our data set. So I really like this this representation, the box plot, because it really summarizes a lot of information in a very simple plot. So let us talk about the central tendency. So this is the formula of the mean. I think you all know how to compute a mean. What is the median? The median is the data point which splits the sorted data into two parts in a way that half of the data lies above and the other half below. So imagine you sort all of your shoe size values along this axis. The median will simply be the middle data point. And as you can see, mean and median represent the central tendency, but they are not necessarily the same. They are separated a little bit here. Now the question we may ask is when to use the mean, when to use the median. I know that classically, in the majority of times, it's the mean that is used, but statistically speaking, the median can be interesting sometimes. Imagine, for instance, you want to minimize the influence of extreme values. Say this point here, okay? So the value of this point will influence the computation of the mean, but not the median. So whether this point lies here or much further away to the right, the median will always be the middle point, whereas the mean will be dragged to the right because of this point. So if you think that data points which are too extreme in your distribution could be wrong or could be not representative of your population, and you want to limit the influence of these data points in the computation of the central tendency of your data, just use the median and not the mean. Also, the mean is only reliable if your data is symmetrical. So if you really have a symmetrical spread of points around the mean. So now we've seen how to describe the central tendency. How can we describe dispersion? So dispersion reflects the extent to which data points are stretched or squeezed around the central tendency. So the most common dispersion indices are the standard deviation. Standard deviation, which is simply the average of all the distances of the points according to the mean. So this is very simple definition of the standard deviation. It's not precisely this, but to simplify things, let's stick to this definition. Then we can also talk about the first and third quartiles, which are more appropriate if you describe your data with the median as a central tendency index. So the first and the third quartiles split the sorted data in a way that 25% of the data points lie above Q3 and 25% below Q1. So this will be much clearer when we'll be talking about box plots, okay? So now let us just focus a little bit more on the interpretation of the standard deviation. How can I interpret the spread of data using the standard deviation? So imagine we have our data points spread along this axis. Okay. And here in red, I just add the mean. This is the mean of the data. This is the length of our standard deviation. So we've computed the standard deviation on our data points, and this is the value we got. So this is the length of the standard deviation from the mean to this dashed line. So if you take the distance from the mean to the second dashed line, you have twice the value of the standard deviation. And if you take the distance from the mean to the third dashed line to the right, you get 3 times the value of the standard deviation. Now the interpretation is very straightforward. If you take the mean plus or minus 1 standard deviation, you capture 68% of the data. If you take the mean plus or minus 2 standard deviations, you capture 95% of the data. And at last, plus or minus 3 standard deviations, you capture 99.7% of the data. So this is a pretty nice way to describe the dispersion of the data around the central tendency, and its interpretation is very straightforward. So this is why it's quite popular in data science reports. But there's something important that should be noticed about the standard deviation. It's only reliable when the mean is reliable, so only when the data is symmetrical. Now let us run descriptive statistics on one quantitative variable in XLSTAT. So I will go back to this specific feature, which is this descriptive statistics under describing data. Now I want to describe quantitative data. So I will select the column I want to describe inside this field, this column, okay? In the output, as you can see, the list of statistics for qualitative data has been deactivated, whereas the list of statistics for quantitative data is now available. So there are many statistics you can choose among: the minimum, the maximum, the quartiles, the mean, the variance, the standard deviation, the skewness, the standard error of the mean, the confidence intervals, and many other things, but I just stick to these for now. Then in the charts tab, so charts 1, which corresponds to the charts relative to quantitative data, you have 2 subtabs. So one in which you can select the charts you want to obtain, so box plots or scattergrams or strip plots. I'll just select box plots for now. And you also have an option which allows you to configure or to customize your different plots. So now I click OK, and once again I obtain a new report, a new spreadsheet. And here, as you can see, we have the different statistics we asked for: the minimum, the maximum, the quartiles, the median, and the mean, the variance, and the standard deviation. Okay, so 95% of my shoe size value lie between 29 minus 2 multiplied by 3.7 and 29 plus 2 multiplied by 3.7. So this is how you interpret standard deviation. Then at last, this is the box plot, which is one of my favorite visualization tools, and which I will comment on my presentation. How can I interpret a box plot? So on the y-axis, you have your the variable you're investigating. First of all, this line in the middle is simply the median. The gray dots are the minimum and the maximum of your data, this one and this one. And as I told you, the median splits the data in a way that you obtain 50% of the data below and 50% of the data above. The orange dot is the mean. So in many statistical software or data science software, box plots are displayed without the mean, but XLSTAT displays the mean. Okay. And here, as you can see, the median and the mean are not the same. They're separated. Then the extremes of this box are the quartiles. The quartiles I had told you about earlier. The quartiles, along with the median, split the data into 4 parts. 4 parts with an equal number of values in each part. So below the first quartile, you have 25% of the data. Above the third quartile, you have 25% of the data. And between the first and the third quartile, you have 50% of the data. So this division of the data in terms of quartiles allow you to have an idea of the dispersion of the data around the median. Okay. So here, as you can see, you have a wider spread of the data above the median because this quantity here is a bit wider than this one. So not only you have an idea of the central tendency in the box plot, but also you have an idea of the spread of the data around the central tendency. There's still one element I haven't talked about in the box plot, which is the whiskers here. What do these whiskers correspond to? These are the Tukey limits. And Tukey limits tell you, in a way, whether there are extreme points in your data. So if the maximum lies above the upper Tukey limit, this means that there's at least one data point which is too extreme in the high values. And if the minimum lies below the lower Tukey limits, this means that there's an outlier, there's an extreme point in the low values in your data. So Tukey limits allow you to investigate the potential presence of outliers compared to the bulk of the data, which is inside here. Now, one last tool I wanted to talk to you about when it comes to describing one single quantitative variable. This is histograms. Histograms allow visualizing the way data are distributed along the possible values of the investigated variable. So histogram divides the variable into intervals and displays frequencies within each interval. What does it look like? And then a histogram looks like this. On the x-axis here, you have the range of values for a variable, so shoe size. The histogram will split this range into several intervals. And then it will count the number of data points within each interval. So for instance, if we take this one, so within this interval from 32.6 to 34.7, we have 3 data points. 3 data points with shoe size between these two limits. Now the histogram allows you to have a view of the distribution of the data. Do you have more data concentrated far below the mean or far above the mean, or is the data more concentrated around the mean? Here we find one abnormal value around 40, thanks to the histogram. How to launch a histogram in XLSTAT? So we simply go to Visualizing Data and Histogram. So here I will simply select shoe size within this field. You should know that there are many options which allow you to configure or to customize your histogram. Here, for instance, I will add a normal distribution for those of you who know the normal distribution to the plot. And there we go. I won't be commenting this line just for the sake of illustrating some of the options of the dialog box. So now we're done in and talking about different tools to characterize isolated quantitative variables. But before switching to next part, which is how to investigate the link between two qualitative variables, I wanted to show you something in XLSTAT. You should know that in most of the features in XLSTAT, you can select several variables within each field. So for instance, if I take Descriptive Statistics, I would just click on this replay button to go back to the dialog box. I can select as many variables as I want under this field. For instance, I want to describe these 4 variables as quantitative and these 2 variables as qualitative. Then in the charts, I select whatever I want. And as soon as I click OK, look, I obtain statistics for each variable. Here we have the statistics for height, for shoe size, for weight, and for time spent on site. I obtain a box plot per variable, and at last we have the statistics for the qualitative data right under, with the associated charts, of course. So this can be done automatically and quite quickly in a few clicks. You can do the same, of course, with histograms. And with all the other tools we'll be checking. How can we describe the link now between 2 qualitative variables? For instance, how can I describe preferred brand according to origin? We have different preferred brand patterns according to origin. So one of the most commonly used methods in this case is the Crosstab, or in statistics we call it the contingency table. This is widely used in survey research. So the Crosstab is a table displaying the frequencies of each possible combination between the categories of the 2 variables. So basically it looks like this. So this is a typical contingency table or crosstab between preferred brand and origin. As you can see, one of the 2 variables is split in rows. So here we have this different categories of preferred brand split in rows, and the other variable is split into columns. So the 3 origins are split in 3 columns. Then within each cell, we have the number or the frequency of the combination of the 2 categories. So for here, for instance, we have 4 clients who come from Earth and who selected brand A as a preferred brand. We have 4 clients who come from Mars who selected brand C as a preferred brand, and so on. In terms of interpretation, maybe it's more convenient to represent things in terms of percentages instead of frequencies. We've computed the percentages per column. So the percentages of preferred brand within each planet. On Earth, the preferred brand is brand C, then you have brand A. Brands D and B are really not popular on Earth, so marketing efforts should be targeted towards brand A and brand C on Earth. In Pluto, we have like an average reference for each brand. How can we launch a crosstab in XLSTAT? I'll go to preparing data, create a contingency table. Go back to my data set here. In the row variable, I simply select the variable which I want to split in the rows of the contingency table. So this will be first brand. In the column variable, I select the variable I want to split in the columns of the contingency table. Then the options tab, or in the outputs, you have several options you can ask for instance, the percentages per rows, percentages per column, and like chi-square per cell by cell, but we won't be talking about this time. Just click OK whenever you're ready, and you get the different outputs that I've been commenting in the presentation. So we've seen how to study the link between 2 qualitative variables. Now, how can we describe the link between 1 quantitative and 1 qualitative variable? For instance, how can I study invoice amount according to origin? So invoice amount is quantitative, origin is qualitative. So what we can do is simply this. We divide the quantitative variable, which is the invoice amount in our case, into subsamples corresponding to origin, the qualitative variable. Then we compute descriptive statistics within each subsample, and we can also draw box plots per subsample. This would be the result. As you can see, we have the quantitative variable on the y-axis in this chart, and the qualitative variable on the x-axis, so Earth, Mars, and Pluto. Therefore, we can investigate the link between both. Here we see that the clients from Pluto have higher invoice amounts compared to the clients from other planets. We also see that clients from Mars have a narrower distribution or narrower spread of the data around the median compared to the two other planets. This means that invoice amounts from Mars are more standard. Maybe people from Mars tend to buy the same product, I don't know. And there are other things that can be investigated in this. And of course, you can investigate things using numbers as well. So here, for instance, you can compare the mean of invoice amount for Earth versus Mars and versus Pluto. We see that in Pluto, the mean invoice amount is quite higher than for Earth and Mars. You can also compare standard deviations, of course, and all the other statistics. Now, how can you obtain this in XLSTAT? I will go back here and I will click replay here. And I will simply select the subsamples column, the column which I will use to divide the data into several subsamples within this field here. So here I'll capture origin. And there's something very important that should be done. We have 3 origin here. So we need to tell this information to XLSTAT under the options subtab of the charts tab. We'll ask XLSTAT to group plots, so to have the 3 plots within the same chart to be able to compare them. And we want 3 box plots. So here we obtain the statistics for each planet. And at last, the box plots. I selected true size. I should have selected the invoice amount, but it doesn't matter. It's the same process. So we can see that true size is doesn't really change according to the origin. But we see that on Pluto, there's someone who has a very weird or very uncommon true size compared to the bulk of the data. Now, last case, how can you describe the link between 2 quantitative variables? And this one is very simple. I think that all of you already have the answers. How can I describe the link between invoice amount and time spent on site, for instance? Well, there are several ways to do so. The most common ways are drawing simply a scatter plot, which is a chart representing one variable on the y-axis and another one on the x-axis. Otherwise, we can also compute correlation coefficients, such as Pearson's coefficient or Spearman's coefficient, which measure the strength of the link between 2 quantitative variables and range between -1 and +1. I won't be spending time on correlation coefficients this time because I will be talking about them more widely and more extensively during the webinar on statistical testing. So just stick to scatter plots for now. So the scatter plot dialog box is very easy to fill out in XLSTAT. And this is what a scatter plot looks like. We have invoice amount on the y-axis and time spent on site on the x-axis. We see that there's a rough decrease of invoice amount according to time spent on site. So how can we configure scatter plot in XLSTAT? I will go to visualizing data, scatter plot. Here in the X field, I simply select the variable I want to display on the x-axis. This is time spent on site. On the y-axis, I take invoice amount. And actually, I will just show you a surprise. I will select several variables here. You'll see what happens. And I click OK. So here's what I obtain. I obtain one scatter plot per combination of y and x. So I have selected only one y, which is invoice amount, and I've selected 4 x's: height, shoe size, weight, and time spent on site. So XLSTAT really automates the computations to avoid having to relaunch the analysis several times. Now I want to ask you one last question right after summing up the webinar. This is all what we've seen so far. How can we describe one qualitative variable? We've seen frequencies, mode, and bar chart. How can we describe one quantitative variable? We've seen statistics to describe the central tendency of the data, how to describe the dispersion of the data. We've also seen the histogram for the distribution, and box plot, which is a synthetical representation. So these are univariate statistics, how to describe variables isolately. Now, bivariate statistics help us describe the link between two variables. So for instance, between two qualitative variables, we've seen the crosstab. Between two quantitative variables, we've seen the scatter plot. Between one quantitative and one qualitative, we've seen multiple box plot within the same chart. Now the question I wanted to ask you, yes. How can we describe the link between 3 variables, 2 quantitative and 1 qualitative? So for instance, invoice amount, time spent on site, and origin. So one solution for this would be to draw a scatter plot between time spent on site and invoice amount, and color according to origin. And this can be done using the groups field in the scatter plots dialog box. And this is what you obtain, basically. There are many things that you can say from this out of this chart. This chart is quite more interesting than the first scatter plot I had already drawn. So we see that invoice amount decreases with time spent on site. We also see that Plutonian customers spend less time on the site compared to the others. Those are the gray dots, and they also have higher invoice amounts. We see that customers from Earth and Mars form a similar group here, a homogeneous group, at the bottom right. And there are many, many things that can be said here, many hypotheses that can be formulated. So we're basically exploring 3 variables using a simple chart. Now imagine having the same kind of reasoning, but on a higher number of variables. So for instance, imagine summarizing the information from 10 variables in a simple chart and having this kind of reasoning, this kind of fishing for information. So this will be the topic of the upcoming webinar, so the day after tomorrow, on exploratory statistics and clustering statistics. So I hope I'll be able to talk to you again the day after tomorrow. Don't hesitate to subscribe. Here are the subscription links. I know that somebody in the questions asked how to subscribe to these webinars. So download these handouts and just click on these links, and you will get, you be sure to have access to them. Now it's time for questions. So what is the difference between n and n-1 in computing the standard deviation? Somebody has noticed that in descriptive statistics, here in the output, we have standard deviation n and standard deviation n-1. So which one should be used? Well, I would say that roughly, really most of the time, you will be using standard deviation n-1. The difference is that if you want to estimate the standard deviation of a population based on a sample, you use n-1. But if you have access to all the data points of your population and you want to compute the standard deviation of your population, use standard deviation n. But most of the time you don't have access to your population, so just stick to standard deviation n-1. Let's see, do we have other questions? How can we know the data is symmetrical at the first place? This is also a very interesting question. So one of the easiest way to check this is just have a look at the histogram. Do you have like a mountain-shaped symmetrical histogram? So do you have a bell-shaped histogram? This means that your data is symmetrical. So if we had like something which looks more like this with a skew to the right or a skew to the left, this is not symmetrical. Otherwise, there are statistical tests, which we call normality tests, that also tell you whether your data significantly differs from a bell-shaped distribution, which we also call a normal distribution. Thank you all for attending and for all the interesting questions you asked. And I really hope I'll be able to talk to you during the next webinar, which is the day after tomorrow. Don't hesitate to download the software, the 40-day trial here, and find us on the different social networks. And after you close the webinar platform, you'll be asked to fill out a survey just to tell us what you thought about this webinar, what can we tell you about during the upcoming sessions. We'll be very happy to hear your feedback. Okay, bye-bye.